Hey everyone, and welcome. Are you ready to grab some guaranteed marks on your CUET chemistry paper? Because you are in exactly the right place. Today we're going to crack the amines code. We'll break down the key tests, I'll give you a master cheat sheet, and we'll even tackle some real exam-style questions. By the end of this session, you'll be an absolute pro. All right, picture this. You're in the exam hall. You get an MCQ with an unknown sample, and it asks you to distinguish between a primary, secondary, and tertiary amine. This is a classic CUET question, an examiner favorite, and honestly, it's somewhere a lot of students trip up. But you won't, not after today. So here's my promise to you. Stick with me for the next few minutes, and we're going to make this topic so crystal clear that you'll literally be hoping it shows up on your exam. Okay, let's jump right in. Okay, first things first, let's nail down the basics. A primary amine, which we call a 1-degree amine, has just one carbon-based group, that's our R, stuck to the nitrogen atom. Now see those two hydrogens bonded to the nitrogen? Pay attention to them. They're the key to everything that's coming up. All right, moving on to secondary or 2-degree amines. Here we've swapped out another one of those hydrogens for a second R group. So now we've got two R groups and just one lonely hydrogen left on the nitrogen. You see the pattern here, right? And you guessed it, finally we have the tertiary or 3-degree amine. Now all three hydrogens are gone, replaced by three R groups. There are 0 hydrogens bonded directly to that nitrogen atom. And this simple structural difference, well, that's the whole secret to telling them apart. So, how do we actually use these differences in a lab setting? Well, we've got a toolkit with 3 super powerful tests: the Hinsberg test, the Carbylamine test, and the nitrous acid test. Let's break down exactly what each one tells us. We're going to start with the heavyweight champion of identifying amines, the Hinsberg test. Seriously, if you only remember one thing from today, make it this test. It is, without a doubt, the most important one for your exam. So how does it work? It's pretty straightforward. We take our unknown amine and we react it with this specific chemical, benzene sulfonyl chloride. You'll often just hear it called the Hinsberg reagent. We do this in an alkaline solution, like sodium hydroxide, and then we just watch what happens. And this is where the magic happens. Just look at these results. A primary amine reacts, and the product it forms still has an acidic hydrogen on the nitrogen. Because of that, it dissolves in the alkali. So boom, it's soluble. A secondary amine also reacts, but its product has no acidic hydrogen left, so it can't dissolve, it stays insoluble. And the tertiary amine, well, it doesn't have a hydrogen on the nitrogen to begin with, so it doesn't react at all. Soluble, insoluble, no reaction. It's that clean. Okay, next up, we've got a more specialized tool. The Carbylamine test is our dedicated detector for just one kind of amine. Think of it less like a shotgun and more like a sniper rifle. It has a very specific target. And here is the golden rule you absolutely have to remember for this test. Only primary amines give a positive result. I don't care if they're aliphatic or aromatic, if it's primary, it'll work. Secondary and tertiary amines, nope, they do absolutely nothing. This makes it an amazing test to confirm if you have a 1-degree amine. So what do we use? We use chloroform and alcoholic potassium hydroxide. If there's a primary amine in there, it produces something called an isocyanide. And how do you know you've made one? Oh, trust me, you'll know. They have an absolutely horrible, foul smell. That awful smell is your signal for a positive test. All right, our third and final test uses nitrous acid. Now, this one's a little bit more nuanced. The results aren't as black and white, they give us different clues depending on the exact structure of the amine. Now, the thing with nitrous acid is it's really unstable. You can't just have it sitting in a bottle. So it's always prepared fresh, right in the test tube, by mixing sodium nitrite with hydrochloric acid. Then you add this fresh mixture to your amine. Okay, listen up, because this is where you really need to focus. The results are very specific. A primary aliphatic amine will start bubbling and give off nitrogen gas. That's called effervescence. But, and this is a huge but, a primary aromatic amine, like aniline, if you keep it really cold, forms something called a diazonium salt without making any gas. That difference is critical. As for the others, a secondary amine gives you a yellow oily layer, and a tertiary amine just forms a soluble salt. The main takeaway for your exam is knowing the different results for the 2 types of primary amines. Whew, okay, that was a lot, right? We've gone through all 3 tests. So now, let's put it all together into the ultimate summary, your master cheat sheet for that last-minute revision. This is where it all clicks. This is it. This is the money slide. Screenshot this, write it down, burn it into your brain. This one table is your key. For Hinsberg, soluble, insoluble, no reaction. For carbylamine, positive false smell for primary, negative for the rest. For nitrous acid, gas or a diazonium salt for primary, yellow oil for secondary, and just a salt for tertiary. This table is going to solve so many MCQs for you. Let's do a rapid-fire recap. Ready? Hinsberg, soluble, insoluble, no go. Carbylamine, primary only, foul smell. Nitrous acid with a primary aliphatic, bubbles. Nitrous acid with a primary aromatic, diazonium salt, but only when it's cold, perfect. Okay, knowing the theory is one thing, but applying it when the clock is ticking in the exam, that's the real game. So let's switch gears. We're going to do some practice questions, and then I'm going to highlight the common traps you need to look out for. First question for you, which test can distinguish between primary and secondary amines? Your options are on the screen. Go on, hit pause and really think about it. Okay, got an answer? The correct answer is B, Hinsberg. Why? Well, think about it. It gives two totally different results. You get a soluble product for 1 degree and an insoluble one for 2 degree. Carbylamine just tells you if a 1 degree amine is there. It doesn't distinguish it from a 2 degree. Question 2. A primary aliphatic amine reacts with nitrous acid to give what? Check your options, pause and pick your answer. The key word here, the most important word, is aliphatic. Ready? The correct answer is C, N2 gas. Remember from our cheat sheet? The diazonium salt, which is option A, is only formed by aromatic primary amines, and only in the cold. And last one, question 3. Aniline, that's a primary aromatic amine, reacts with nitrous acid at 0 to 5 degrees Celsius and forms what? Look at your options, pause the video, and lock in your answer. The correct answer is, of course, B, diazonium salt. This question is testing that very specific condition we talked about. The low temperature is the big clue that you're forming the stable salt. All right, listen up. I'm going to get serious for a minute. These are the traps you have to avoid. 1. Forgetting that tertiary amines do nothing in the Hinsberg test. 2. Thinking the carbylamine test works for anything other than primary amines. 3. Mixing up the nitrous acid results. N2 gas is for aliphatic, diazonium salt is for aromatic. 4. Forgetting that the cold 0 to 5 degree condition is essential for that diazonium salt. And 5. Getting the Hinsberg solubility mixed up. Just remember, the primary product is soluble because it still has that acidic hydrogen. Don't let these simple mistakes cost you marks. So, how'd you do on the practice questions? Did you get all 3? Let me know your score down in the comments. And hey, if you missed one, just go back and review that specific test. Mastering this stuff is a team effort. You've totally got this. Keep practicing, and I'll see you in the next one.